Okay, these are the solutions to CCEA's GCSE Further Mathematics Unit 1, Paper 1, which is the Pure Mathematics module. Right, first question says, find dy by x if y is equal to 8 x to the 4 plus 4 over 5 x squared plus 3. So the first thing you've got to do here is get this in index form. So rewrite the question. So to get it in index form, I wouldn't normally do this, but I'm just going to do this time. This term here could be written as 4 over 5 times 1 over x squared plus 3. And then we could write that as 4 over 5 times x to the minus 2 and then plus 3. And then that makes it a wee bit easier. Normally I would just jump straight to this line, but just to show all the steps. And then here, differentiating, remember you multiply by the power and then you reduce your power by 1. So the 4 comes down and multiplies 8 to give you 32, and the x to the power 4 goes down to x to the power 3. And then you multiply by your power, so minus 2 times 4 over 5 is minus 8 over 5, and I would leave it as that. And then you reduce your power by 1, so it goes down to x to minus 3. And 3 differentiated just gives you 0. So that is it. I'm not too sure if this would give you the right answer because of the way the question is written. So because they had a power on the bottom line, I would probably put it back into that form. So that's 32 x to the power 3, and I'll take a couple of steps to do this next bit. This thing then is then 8 over 5 times 1 over x to the power 3, and then you can see that's 32 x to the power 3, and then minus, multiply along the top then, you've got 8 times 1, multiply along the bottom, you've got 5x cubed, and that should be you definitely done. So I'd imagine that's how you get your full marks there for that question. Question 2, similar idea to start here. This is an integration question, but what you want to do is get it in an index form before you can move on. So that's what we have got, an index form. And then integration is a reverse of differentiation. So you're raising your power by 1 and dividing by your new power. So it's now x to the power 5, and then divided by 5 over here. Add 1 to minus 3. This is what people always go wrong on. Add 1 to minus 3, you will get minus 2, and then you're dividing by your minus 2. So we'll sort this out next stage. Then 1 integrates to give you x, and remember your constant of integration, c. Now we just have to tidy up. 2x to 5 over 5, and then minus divided by minus is a plus, and also that's going to be positive, and then that is really, we could split this term up as being 1 over 2 times 1 over x squared, and plus your x plus your c, and then that's 2x to the 5 over 5, and then the middle term here, 1 times 1 is 1, 2 times the x squared is 2x squared, and then plus your x and plus your c, and that should give you the full marks. Okay, question 3 is a matrix question. You've got your 3 matrices set out, and then it says for you to find b plus c. So b plus c just means you're adding the two things. So I'll just write down my 2 matrices that I'm working with, and I'm adding them. And when you're adding matrices, all you're doing is adding the corresponding elements. So the first, it's going to be a 2 by 3. So 2 plus minus 4 is going to be minus 2. 1 plus 1 is 2. 1 plus minus 7 is minus 6. Minus 1 plus minus 2 is minus 3. 2 plus minus 2 is 0. 4 plus 0 is 4. And that should be it. If I've done that correctly, that should be right. Next thing you have to do is find AB. So to find AB, this is us multiplying our matrices. So you've got A times B. Let me write these down. What A is 1, 3, minus 1, 4. 1, 3, minus 1, 4. And bear with me a wee second here. 1, 3, minus 1, 4. And my B is, it was 2, 1, 1. 2, 1, 1, minus 1, 2, and 4. Okay, to do this, first of all, let's look at the order of these matrices. This one is a 2 by 2. This one is a 2 by 3. So what I mean by a 2 by 2, there's 2 rows and 2 columns. And this one the second one has 2 rows and 3 columns. So my resulting matrix will be a, and you just take the outside things. First of all, because these two are the same, that shows that they're what's called compatible. And then you take the outside things, and that's what you're going to get. It's going to be a 2 by 3, is my resulting matrix is going to be a 2 by 3. So it's going to be, as I've just said, it's a 2 by 3 is a result. So we'll leave enough space for that. So how you get this first element, so how you say the position of the element is important. So it's a first row, first column, which means you multiply the elements in the first row of the first matrix by the elements in the first column in the second matrix. So you're doing, really what you're doing to get this one, I'll just do it for this one thing, it's be 1 times 2 plus 3 times minus 1. 1 times 2 is 2, 3 times minus 1 is minus 3, so 2 minus 3 is minus 1. We'll do the first, the top row here, so we're doing first row times second column here, so 1 times 1 plus 3 times 2 is going to be 1 plus 6, which is going to be 7, and my first row times my third column, so 1 times 1 is 1, and 3 times 4 is 12. 1 plus 12 is 13. So hopefully I've done those right. Now the second row then, so second row times the first column is minus 1 times 2 is minus 2. 4 times minus 1 is minus 4. Minus 2 minus 4 is minus 6. And then second row, second column is minus 1 times 1 is minus 1. 4 times 2 is 8. Minus 1 plus 8 is going to be 7. And then last one, which is going to be the second row, third column, so second row times the third column, minus 1 times 1 is minus 1, 4 times 4 is 16, minus 1 plus 16 is 15. And obviously you can do that on your calculator. Okay, part B of this question is a matrix question as well. You've got matrices which are L and M are defined by this, and it says find x such that Lx equals M. So what you can say then, L times x is equal to M, and you want to find x. So had these been normal letters, you would have said M divided by L, but because it's matrices, you cannot just divide as such by a matrix. So what you've got to do is cancel out that L. So you cancel out that L by multiplying by the inverse of L, and notice here the inverse of L comes in front. That means the inverse of L has to come in front of the M on the other side as well. So that's really what you want to do here. So I'm going to write down what my L is, and what will happen then, L, inverse of L times L just becomes the identity, times x is equal to the inverse of L times M, and the identity of any matrix just gives you the thing, whatever it was, so you're multiplying, so it's equivalent of multiplying by 1. Like 1 times 7 is just 7. So the identity times x is just x. So that's really what we need to do. So here we've got to find the inverse of L. So let's write down what our L is. L is 5 minus 3 minus 1, minus 4. And first of all, your determinant is the product of the leading diagonals, so 5 times minus 4, minus the product of the other diagonals, so minus 1, minus 1 times minus 3, which is going to be minus 20, minus, and then that's going to be plus 3, which is going to be an ugly number, minus 23. Hopefully that's right. And then we will just do your inverse. So your inverse is 1 over the determinant. And then what you do is you swap the elements in the leading diagonal. So the 5 and the minus 4 swap around. And you change the sign of the other elements. So that minus 1 and minus 3 become positive 1 and positive 3. Okay, we'll put this back into this equation then. That means your x is going to be equal to, and your inverse of L was minus 1 over 23 times minus 4, 3, 1, 5. And your M from earlier on, if I can see it, was 2, minus 6, 5, and 3. And then we're gonna multiply that out and see what we get. So leave the minus 1 over 23 to the end. We're going to hope that this cancels down a wee bit nicer. We will see. And it's a 2 by 2 times a 2 by 2, so the resulting matrix is going to be 2 by 2. And I'm just going to check these with my calculator. So my first row, first column is minus 4 times 2 plus 3 times 5, which works out to be 7. And then you're going to have minus 4 times 3, minus 4, sorry, times minus 6, and then plus 3 times 3, which works out to be 33. And then you're going to have bottom row, so this is second row, first column, so 1 times 2 plus 5 times 5, which works out to be 27. None of these are working out particularly nicely. And then 1 times minus 6 plus 5 times 3, and that works out to be 9. So that's what we have got. If I got this in an exam, I would be checking this very closely, so I'm going to do that again just to make sure I've done this right. Right, where's my inverse of it? Where's my L? There's my L here. My determinant is 5 times minus 4, which is minus 20, and then that's going to be minus 1 times minus 3, which is 3. So minus 20 minus 3 is minus 23. And then swap the elements in your leading diagonal, change the sign of others. Yes, we've done that. That looks right. It's just an ugly answer, but definitely in an exam, I would be checking that just to make sure I hadn't made any silly calculation errors. Okay, this next question is a bit of a weird one that they have done, and it's weird because not because they're asking to plot the graph of sine x, but because of the range. So it's a range that you probably don't know. So if I was doing this myself, if I'm quite honest, I would do exactly what I'm doing now, is I would do a wee sketch of your sine graph. So your sine graph from 0 to 360, that's what it looks like. There's 360, there's 180, and it goes from it goes from minus 1 up to 1. So that's what your sine graph looks like from 0 to 360. So if you imagine that as then just, if you just go back the other way, it'll just continue. If I just go over here and do that, it will just continue this way. So it'll be going down first and then up. So there's minus 360. So it just continues on. So start by doing a sketch of the bit that you know. And if you don't know that, you really should have learned that for your exam. And then you really just sketch on, go back the way. So again, I'm going to pause the video and just do this and then talk through what I've done. Okay, so here I've got my graph drawn. I've just done my 5 wee squares for 90 degrees, so sort of it divides up nicely a sine graph or a cos graph in every 90 degrees. So this wee section here is the same as over here. So I've just on my axes, I've done 0, minus 90, minus 180, minus 270, and minus 360. And my vertical, it goes from 1 down to minus 1. So its sine of 0 is 0. It's calculator exam, you can put these in just to check, but check every 90 degrees. Sine of minus 90 is minus 1. Sine of minus 180 is 0. Sine of minus 270 is 1. And sine of minus 360 is 0. So you can just check, put those in and check. Okay, part B. Part 1 is solve the equation. So we've got 5 sine x minus 4 is equal to 0, which means 5 sine x is equal to 4, which means sine x is equal to 4 over 5. I'm going to use the cast diagram method to do this, so I'm going to find my basic angle. So from my calculator, I'm doing sine to the minus 1 of 4 divided by 5, and press equals, and to 1 dp, that gives me 53.1 degrees. So I'm going to draw my cast diagram. And again, it's a weird one here because they're going between minus 360 and 0, so you're going back the way. So going back the way, that's going to be minus 90, minus 180, minus 270, and that's going to be minus 360. And it's a cast diagram, C, A, S, and T. And if we look back to this line here, our sine was positive, which means we're looking at the places, going to draw our angle in the places where sine's positive. And sine's positive here, and sine's positive here. So you're marking your angle, always with the horizontal, so 53.1 degrees. And what we're looking for then, we're looking for this angle, first one, which is all the way around to here. And then we're looking for this angle, which is all the way around to here. So my two answers are going to be x is equal to minus 233.1 degrees and minus 306.9 degrees. Okay, and again, you can check one of those. So put it back into the original equation. I'll just do the first one, the minus 233.1. So I'm going to do 5 times sine of minus 233.1, close that bracket, take away 4, and hopefully I get something close to 0. And yes, I have got something very close to 0. So I am happy. Oops, I'm happy with that. Okay. Okay, the next question says, hence solve the equation. So it's the same, almost the same thing. 5 sine 2 theta plus 8 minus 2, which is on equals 0, which is on a slightly different range. So first thing we're going to do is we're going to write down the equation again. 5 sine 2 theta plus 8 minus 4 equals 0. And we're going to adjust our range. So instead of it being minus 180 to theta, it's 2 theta plus 8. So do that to the 0. 2 times 0 plus 8 just gives you 8. Do that to the minus 180. So you're going to have 2 times minus 180 is minus 360, and then plus 8 gives you minus 352. So if you remember back to what we have just done, we in the previous example we did 5 sine x minus 4 equals 0. And we solved it to find that your x was equal to, and I've forgotten already, our x is equal to, and it was minus 233.1, and the other one was minus 306.9. So that means that's what these things are going to be equal to. So we're going to put that equal to in this case. So we'll go back to our blue pen and we'll put 2 theta plus 8 then is equal to minus 233.1 or minus 306.9. Then you have two linear equations. So the first thing I'm going to do is take 8 away from each of them. So what was it? Minus 233.1 minus another 8 is going to work out to be minus 241.1 degrees. And then we had minus 306.9 minus another 8, which works out to be minus 314.9 degrees. And then your theta, divide those both by 2 and see what you get. Just have that one done first. It was on my calculator, and as we have that one, and then you had the 241.1 divided by 2, and that's going to be minus 120.55. So our answers then, I'm guessing we have to go this to 1 dp again, so 120.6 degrees, 157.5 degrees should be the answers. Now just check that it's in your original range here. Our range was, oops, I've lost a wee minus there. Our range was from minus 180 to 0, and both things are in that range. So that looks good to me anyway, unless I've made a wee mistake somewhere. Okay, question 5 is a logs question. It says if p is equal to log to the base 4 of x and q is equal to log to the base 4 of y, write log to the base 4 of 4x squared y square root of y in terms of p and q. Okay, we're going to write this thing down, and then we're going to see how we can change it using our various rules of logs. Okay, so that's what we had. Using our first rule of logs, we're going to split this up. This is log to the base 4 of 4 plus log to the base 4 of x squared plus log to the base 4 of the square root of y. Now, a log of a number is a part of which the base must be raised to give the number. Log to the base 4 of 4 is just 1. You can check that on your calculator using your log button. This next thing, log to the base 4 of x squared, using your third rule of logs, you can write that as 2 log to the base 4 of x. And this really is log to the base 4 of y to the power of a half. So that half can then come out the front, and that's a half times log to the base 4 of y. And then I think that's us ready to put it back in terms of p and q. You have 1 plus log to the base 4, remember, is p, so that's 1 plus 2p, plus a half times log to the base 4 of y is q, And that is your answer. Next one says solve the equation. That's us using our logs then. We have got 7 to the power of 3 minus 2x is equal to 5 to the power of 4x. First of all, you'd have a look and see, can I use indices to do this? But you can't use indices to do this, unfortunately, as there's no number where you can make the bases the same when you've got 7 and 5. So just say take logs. So I'm just using the base 10. So log 7 to the power of 3 minus 2x is equal to log of 5 to the power of 4x. And then again, by using your third rule of logs, that's 3 minus 2x times log 7 is equal to 4x times log of 5. And then multiplied, you'll have 3 log 7 minus 2x log 7 is equal to 4x log 5. Bring all the x terms to one side. I'm going to fire all my x terms to the right hand side to make them positive. So that's 4x log 5 plus 2x log 7. And then factorize, pull an x outside of bracket. Sorry, I'll write that down again. Factorize, pull an x outside of bracket leaves you 4 log 5 plus 2 log 7. And then divide across by that. You'll have your 3 log 7, nice horizontal line, divided by 4 log 5 plus 2 log 7 is equal to your x. Fire that into your calculator to get what your x is equal to. And I'll just do that now. And I took a wee second to do that in the calculator there, and to 3 sig figs, I got x equals 0.565, and again, that was to 3 sig figs. Okay, question 6 says, the sum of a number x and its reciprocal is 8. Show clearly that x squared minus 8x plus 1 equals 0. Absolutely no idea. Right, let's read that again. The sum of a number x plus its reciprocal. So the reciprocal of a number is 1 over it. So the sum of those two things is equal to 8. Okay, right? And that's what we have. And then if we multiply through by x, you're going to get x squared plus 1 is equal to 8x. Oh, happy days. And then bring that across. Bring the 8x across. You'll have x squared minus 8x plus 1. And that's it. Lovely. Okay, it says in this question, hence, using the method for completing the square, solve the equation x squared minus 8x plus 1 equals 0. So to do this using completing a square, first thing I like to do is just isolate the x terms. So that's the x and the x terms, I call them just the x terms. And then I'm going to complete the square inside this bracket. So to complete this square, I need to add in, and I always add in, half of the coefficient of x squared. So because I've added it in, I need to also take it away outside the bracket to keep things balanced. Now this whole bit here can just be reduced to x minus 4 all squared. And then outside you've got plus 1 and then minus plus 1 minus and then minus 4 squared is going to be 16. So that's what you've got. So you've got x minus 4 all squared. Then minus 15 equals 0. And then we can go about solving this. So we'll leave the x minus 4 squared here, fire the 15 across, becomes plus 15, and you have x minus 4 is equal to plus or minus the square root of 14, and your last line x is equal to 4 plus or minus the square root of 15. Question 7 is a quadratic inequality question. It says, solve the inequality and you must show clearly each stage of your solution. The first thing I would do is I bring my terms across just so that your x squared term is positive. It makes life so much easier. And then I'm going to just forget about the inequality and just put 0 equal to this thing at the moment. And then I'm going to solve this. So this is a sum and product method type question. You could just, if you wanted to, you can use a quadratic equation. I'm going to use a quadratic formula. I'm going to use a sum and product method just. So minus 60, how do you get minus 60? Minus 1 times 60. Not going to work. Minus 2 times 30, that's not going to work. Minus 3 times 20, that's not going to work. Minus 4 times 15, that's not going to work. Minus 5 times 12, that's not going to work. And minus 6 times 10, if you multiply minus 6 and 10, you get minus 60, and if you add them, you get 4. So that's what I want. I just do a curly line, that's minus 6 and 10. So all this does, it tells you to rewrite your middle term. So the 4x now becomes minus 6x plus 10x minus 12. And we'll factorize the first two terms completely, which is what I haven't done. Factorize the first two terms completely. All you can do is pull out an x term, leave you 5x minus 6. Factorize the second two terms completely. All I can do is pull out a 2, leave me 5x minus 6. If you see you've got the same bracket, you know you're on the right track. So 5x minus 6 upon x plus 2. And then that means x is going to be equal to 6 over 5, which is the same as 1.2, or here x is equal to minus 2. So what that allows us to do then is then draw the quadratic. So it's a positive quadratic, so it's a U shape. Crosses at minus 2, and it crosses at 1.2. And if you look back to your equation, this bit here, we wanted our thing to be less than 0. So we want when this thing is underneath the axes. So we're looking for this wee section. So our answer is minus 2 is less than or equal to x is less than or equal to 1.2, and that's it. Okay, question 8. We're getting on to the trickier questions really. Our calculus questions, differentiation, integration, and so on. This says a curve is defined by the equation y is equal to 2x squared. Find the equation with tangent to the curve at the point where x equals 3. So I'm going to tangents. Here tangent mentioned, you're thinking dy by dx. Differentiate, you'll get 4x. And then we'll just say when x equals 3, your dy by dx is equal to 4 times 3, which is 12. So far your tangent is 12x plus c. Now to find this c, we need to find the corresponding y value. So we're going to put x into this thing. So when x equals 3, y is equal to 2 times 3 squared. So y is going to be equal to 2 times 9, which is going to be 18. So we're going to sub the point 3, 18 into the curve. Y is equal to 12x plus c, which is going to give you 18 is equal to 12 times 3 plus c. So 18 is equal to 36 plus c. 18 minus 36 is equal to your c. So that's minus 18 is equal to c. And then rewrite your equation. Y is equal to 12x minus 18. And that is it done. Okay, part 2 of this question, it refers back to the first part of the question where the curve is y is equal to 2x squared. So that's why I've written that there. It says at a point A on the curve, the gradient of the normal is 1 over 8. So the gradient of the normal is equal to 1 over 8. That means the gradient of the tangent is a negative reciprocal of that, which is minus 8. So remember, our dy by dx, we had found out earlier on, our gradient function is 4x. So what we're going to do is put minus 8 equal to 4x and find out then what the corresponding x value is. So minus 8 divided by 4 gives you your x. So your x is minus 2. So we know for our point A, the x value is 2. So we'll just say minus 2, the x value is minus 2. When x equals minus 2, y is equal to 2 times minus 2 squared, which means 2 times 4. So y is equal to 8. So your point A is minus 2, 8. Okay, good bit of work to do in this one. Hopefully I don't make any mistakes here. This very easy to do, make a mistake in this question. But show all your steps and multiply your brackets a long way. So we've got 2x plus 3 cubed, which means 2x plus 3 upon 2x plus 3 upon 2x plus 3 minus 6x minus 1 squared. So 6x minus 1 squared. And then we're going to multiply this out. I'm going to do this in a couple of steps, a good few steps actually. I'm going to multiply the second double pair of brackets. So 2x times 2x is going to give me 4x squared. 2x times the 3 is going to give me 6x. 3 times the 2x is going to give you 6x. And 3 times the 3 is going to give you 9. Over here, I'm going to have 36x squared minus 6x plus 1. I'm rushing through this here. And then what you would do, and what a lot of people don't do, is tidy up. What you should do really is tidy up. It makes it so much easier. So over here, tidy up anything that you can. So I've grouped my x terms to make it a wee bit easier. And then I'm going to multiply it again. Multiply it again, I'm going to have 8x cubed. Is that right? Yep, 8x cubed plus 24x squared plus 18x, that was multiplying my big bracket by the 2x, now multiplying by the 3, I will have 12x squared plus 36x plus 29, and then I'm minusing my 36x squared, minus 12x is plus 12x, and minus 1 is minus 1, and then your last line tidy up, and you'll have 8x cubed, and your quadratic terms, you have 24 plus 12x squared minus 36 at 0, they disappear, okay, and then your x terms, you have 18 plus 36 plus another 12 is going to be 66x, and then you've 27 minus 1, which is, 27 minus 1, which is 26. So hopefully I've done that correctly. Part B says, express this thing as a single fraction in its simplest form. So the first thing you want to do is factorize everything. The first thing, top left, you've got a difference of two squares. Bottom line, you can't do anything with it, but I would just put it in a bracket. It makes it a wee bit easier to see just when you're doing your cancelling. And then this thing is going to factorize to be 2x minus 1 times x plus 1. And the bottom line factorizes, you pull out a 5. So it's 5 upon x plus 1. Okay, once you've factorized, and only once you've factorized, then flip your dividing fraction. So write down the first bit, it hasn't changed, nothing has changed here. Flip your dividing fraction and it becomes multiplying. So you have x plus 1 over, 5 upon x plus 1 over 2x minus 1 upon x plus 1. I'll use a different colour pen to show my cancelling here. Cancel whatever way you want. What I see first, I have a 2x minus 1, and 2x minus 1 it goes. I'll use green then for the next one, and then you could have cancelled this one and this one. I'm just going to do this one and this one just because they're above each other, makes it a wee bit easier to see. Doesn't matter as long as you only cancel one on the top and one at the bottom. And then I think that's as good as we can go. Now you're left to multiply on the top. You've got 5 times 2x plus 1 on the top, and the bottom line is x plus 1 and that's it. Okay, now that should get you your marks. There's nothing wrong with that. But I would, just to be sure, I would multiply it out. Make sure you multiply it out correctly, just to be guaranteed getting your marks. But I would imagine that would get you your full marks. I imagine that definitely would as well. Question 10 said, a curve is defined by the equation y is equal to x cubed plus 3x squared minus 20. Find the coordinates of the turning points of the curve, and using calculus identify each turning point as either a maximum or a minimum. Okay, so as a dy by dx question, differentiate then. And you're going to get 3x squared plus 6x. And then we're going to put 0 equal to 3x squared plus 6x. And if you do that, you'll have 0 is equal to 3x upon x plus 2. So x is equal to 0 or x is equal to minus 2. We need then to, we need to test these things, see if they're positive or negative when you put them through d2y by dx squared. So find your d2y by dx squared first. It's going to be 6x plus 6. So when x equals 0, d2y by dx squared is going to be 6 times 0 plus 6. So it's just going to be 6, which is greater than 0, which tells you it's a minimum turning point. It's one of these weird things in mathematics. It's the opposite. Well, opposite is what you would have thought. So it's greater than 0. You would have thought as maximum, but greater than 0 actually indicates it's a minimum. And the other one then, we'll just say when x equals minus 2, your d2y by dx squared is equal to 6 times minus 2 plus 6, which works out to be minus 6, which is less than 0, which tells you it's a maximum turning point. Now, we haven't quite found our turning points. We also need to find the corresponding y values. So we'll just say when x equals 0, y is equal to, and you were putting it back into the original equation here. What was that? X cubed plus 3x squared minus 20. So it's going to be 0 cubed minus 3 times the x squared minus 20, which of course is just equal to minus 20. So tidy up your answer. 0 minus 20 is a minimum turning point. Same idea over here. We'll just say when x equals minus 2, your y is equal to minus 2 cubed plus 3 times minus 2 squared minus 20. So y is equal to minus 16. So that tells you minus 2 minus 16 is a maximum turning point. And that's our question done. Okay, I've just written down for the next part of the question, I asked you to sketch this curve. It's a quadratic curve, it's a cubic curve, positive cubic curve, so it's that sort of general shape. But we also know the turning points. I've written them from earlier on. We know the turning points are here. So it also says the curve crosses the x-axis only once at the point 2, 0. So I'm going to mark that on 2, 0. 2, 0 here. And also we cross at 0 minus 20 is a minimum, and minus 2 minus 16. So somewhere here we're going to imagine. So when we draw a curve, it's going to look something like this, with your maximum, minimum, and then crossing at 2. So there's 2. We'll mark on these points just to make it really obvious. Guarantee getting our marks. And that was minus 20. And that should be it. Hopefully get us our marks. Next part of the question says, hence find the area enclosed by the curve, the y-axis and the positive x-axis. So we're looking at this area here. I'm going to shade it in and mark it as my area. So basically we're integrating our curve. Our area A is going to be the integral between 0, x equals 0, x equals 2 of our curve. And I'll need to go back and find out what my curve is. X cubed plus 3x squared minus 20. And then if we integrate that, we will get, so square bracket now we've integrated, it's going to be x to the 4 over 4 plus 3x cubed over 3, which is just x cubed, minus 20x, and that's between 2 and 0. So firing in 2 into that, first of all, 4 to the power 4 divided by 4 is going to be 4. That was 2 to the power 4 divided by 4 is 4. Then 2 cubed is going to be 8, and minus 20. And putting 0 into it, 0 and the power 4 is 0, 0 cubed is 0, minus 20 times 0 is 0. And then that just works out to be minus 8. So your answer, the area, is equal to positive 8 units squared. Okay, it was only minus because the area was underneath the graph. So that looks like a sensible answer for this question. Okay, question 11 is a simultaneous equations question. It says a car rental company has economy, standard and luxury cars. Every rental involves a daily hire charge, a fuel charge per mile, and a daily insurance charge. So for an economy car, X represents the daily hire charge in pounds, Y represents the fuel charge in miles in pounds, fuel charge per mile in pounds, and Z represents the daily insurance charge in pounds. So it says it costs £150 to hire an economy car for 5 days. So you have 5 days, so 5 times X, 600 miles, so 600 times Y, and also your daily charge, your daily insurance, so 5 lots of it, so you have Z because you have 5 days, and that comes to on £150. If you divide that all by 5, you will get X plus 120Y plus Z is equal to 30 as required. So you can see you've got your answer. For the next part, the second equation for a standard car, the daily hire charge is £8 dearer than the economy. The fuel charge per mile is the same. The daily insurance charge is 50% dearer. And then for economy, and it costs £344 to hire a standard car for 8 days this time, travelling 1,400 miles. So you've got 8 days, but your charge now is £8 dearer, and you travel 1,400 miles at the same cost, so the same Y, and you've got your 8 days worth of insurance, and insurance is 50% dearer. How you do 50% dearer is multiply by 1.25, so 1.5 times Z is equal to 344. Multiply that all out and tidy up, you'll have 8x plus 8 plus 1,240Y plus 12Z is equal to 344, and then that becomes 8x plus 1,240Y plus 12Z is equal to, bring the, what am I bringing across here? I'm bringing Oh, it's 64, that should have been, apologies. Over here, that was 8 times 8. I forgot to multiply. Is 64, so bring it across, and that's going to be 280. And then if we divide through by 4, we're going to get the answer that we wanted, which was 2x plus 310y plus 3z is equal to 70 as required. So you know you've got your 2 marks. Okay, next bit was for luxury cars. So the daily hire charge is 3 times that for an economy car. Fuel charge per mile is 50% greater, and the daily insurance is 2.5 times greater than that for the economy, and it costs £119 to hire a luxury car for only 2 days, travelling 150 miles. So you've got 2 days, but the cost instead of being x is 3x. You've got 150 miles, and it costs 50% more, so 1.5 times your original y, and then plus 2 times, because you've got 2 days, but the insurance is 2.5 times greater, and that costs you £119. So to get this one, it's just tidying up. So if you tidy up, you're going to get 6x plus 225y plus 5z is equal to 119, and that's how you get your equation 3. Okay, the next bit says actually solving the equations. So even if you couldn't get those previous 5 marks, they've been very nice to us, and they've given the equations for us to solve. So the first thing I do is I just call them, give them a name, 1, 2, and 3, and you'll see why. Right, we've got a system of 3 equations. I want to reduce this to a system of 2 equations, and I'm going to decide to eliminate, so I've just abbreviated that to eliminate x. So I'm going to do that by, first of all, multiplying my first equation by 2. So it's going to become 2x plus 240y plus 2z is equal to 30. I haven't left myself enough room here. Is equal to 30, and that was 2 times equation 1. I'm going to write my equation 2 underneath it. That was my equation 2, and I'm going to do equation 2, take away my 2 times equation 1, and that's going to give me a new equation 4, which will have no x in it. So if I do that, I will get 70y plus z is equal to, and if I could multiply by 2, it would be good. 2 times the 30 is 60. So then 70 minus the 60, is 10. So that's my equation 4. Okay, I'm also going to use eliminate x from equation 1 and 3. So I'm going to multiply my first equation by 6 to get the same number of x's. So I'm going to have 6x plus 720y plus 6z is equal to 180. I'm going to write down my equation 3 underneath it again. So that's going to be 6x plus 225y plus 5z is equal to 119. And I'm going to subtract, take those away. I'm going to do the top one minus the bottom one, just makes life easy. And then I will have 495y plus z is equal to 61. And that's also my equation 4. So I'm going to solve now equation 4 and 5. So equation 4, I'm going to write underneath it again. It's 70y plus z is equal to 10. That was my equation 4. And I'm going to then just subtract. So equation 5 minus equation 4. And that will get me 425y is equal to 51. Y then is equal to 51 divided by 425, which seems weird. It is 0.12. But if you think what that was your cost in pounds per mile. So it costs you 12 pence per mile on fuel, which sounds sensible. Or it did a few months ago. And then we're going to sub that into equation 4. So sub that into equation 4. So our equation 4 was 70 times the 0.12 plus the z is equal to 10. A wee bit of working out then. 10 minus the 70 times 0.12. You don't have to show all the steps here. You don't have to actually work that out. You just do that in your calculator and you will get 1.6. Okay, because it's money I'm talking about, I'm going to put a second decimal place in here. not that it matters until the answer line. So you've got all of that so far. What we're going to do then is we're going to put that into equation 1. So sub that back into, both of those back into equation 1. So sub that into equation 1 and you will have x plus 120 lots of 0.12 plus 1.60 is equal to 30. And then that's going to give you x is equal to 30 minus the 1.60 minus the 120 lots of 0.12, which gives you x is equal to 14. Okay, you can go on and check that. I'm going to just do that now in my calculator, check it on equation 2. So 2 times the 14 plus 310 times 0.12 plus 3 times my z, and where on earth is my z? 1.6. And I've done that, and it gives me 70, so it does work. So you don't have to write down your check, but just it's good practice just to check it. And then I managed to get out into one space, but just fill that in. X is equal to 14, y is equal to 0.12, and my z then was equal to 1.60, and that is it. Okay, this one I think is probably the hardest question on the paper. Just quite a bit to do, and I haven't made it very easy for us. It says Willow recorded the mass m and the metabolic rates r of 5 mammals. The results were given in the table below. So you've got all these masses, and it says Willow believes that a relationship in the form r is equal to a plus m to the power of m exists, where a and n are constants. Verify that a relationship of the form r is equal to am to the power of am to the power of n exists by drawing a suitable straight line on the grid opposite and label the axes clearly. And it says show clearly the values used corrected 3 decimal places in the table above. So just have a look ahead. We've got a wee graph for us to draw, but we have to do our values first of all. So before I do this, what I like to do is I just like to figure out how will this be a straight line. So we're going to just take logs of this thing. So we have got, remember, r is equal to am to the power of n. I would take logs. That means log of r is equal to log of am to the power of n, which means log of r is equal to log of a plus log of m to the power of n. And using your third rule of logs, log m to the power of n can be written as n times log m and then plus your log of a. So here we are going to be plotting on the horizontal axis, we're going to be plotting log m, we're going to be plotting log r in the vertical. This really is equivalent to like y equals, sorry, making a mess here, y is equal to mx plus c. So here n will be the gradient, and if we can see it, log a will be the y-intercept. Okay, so when we plot this thing, so if you imagine I plotted that thing and that's what you're going to get, the gradient will be given by n, and log a, wherever that happens to be, will be the gradient, but quite often you can't see your gradient, or your gradient doesn't work out just so well. So we'll go back. First of all, before we do all that, we have to take 2 columns. We have to have a log m and a log r. I'm going to pause the video and write these all in. You're just firing these into your calculator. The first one, for example, you're doing log of 6.5 and it comes out as 0.813 and so on. And log of r is going to be 0.332. So that was when you did log of 2.15. I'm going to pause the video and do all of these by magic. Okay, there you go. And we were told to do them to 3 decimal places. We can now plot these on our table. So you can pause the video if you want to see those, copy those down or whatever, but we'll go on to our table. So we're plotting, remember we said log m and then log r, and you're plotting all of those points on the corresponding table. So I will again pause the video and do that. This is not going to be perfect. Okay, I have plotted those as best as I could, and then just draw a straight line through them. So again, I'll pause the video and draw a straight line, and you can see we've got our straight line. Okay, right. We have to just say something along the lines of the straight line so relationship exists. Okay, right. The next part of the question asks us to say, it says, hence find the values of a and m. So remember back here, we said that your n is your gradient and log a will be the intercept. We cannot use our graph to find the intercept, so they're being a wee bit nasty to us here. That's just the way it is. We want to find the values of a and n, so we'll do, say the gradient is equal to n, and it is equal to your log r difference over your log m difference. You may have learned this a different way, rise over run or whatever you have happened to have done, but we're going to do this. Okay, right. I am sort of using my graph, sort of not. I'm going to use this first point and the last point that we got. So I'm going to use my triangle I'm going to draw is here. But this point here, if I go over it, and this point, I'm actually using the values from the table. So I'm going to use these values. So I've got my log m values and their corresponding log r values, and that's what I'm going to use on my table. Or sorry, that's what I'm going to use to work out my gradient. So it is, if I have done this correctly, 1.621 minus 0.332 divided by 2.653 minus 0.813. And when I worked that out, I got an exact answer of that. But we had to give our answers to 2 dp's, so it was 0.70 to 2 decimal places. Okay, the next bit then to find the log a, and then to go on and find a, we can't use our intercept as it doesn't. It didn't go through. It wasn't on our graph, unfortunately. So we're going to have to put it into the formula. Log r is equal to n log m plus log a. You could also put it back into the original equation, and now that you know the value of a, and do use corresponding values of r, and that would work just as well, may even be a bit easier. But I'm going to use this, and I'm going to use my first of my points, which was my log m value is 0.813, and my log r value is 0.332. So put that in, you're going to have 0.332 is equal to n, which we now know. I'll use the exact value of it, which we had was that, times log m, which was 0.813, plus log a. Good bit of working out, well, wee bit of working out, you'll have your log a is equal to minus 0.237541. Use your inverse log button on your calculator. You'll get 0.57870, which means a is equal to 0.58 to 2 decimal places. So there we have that whole thing, and then a was 0.58, 2 decimal places, and n is 0.70 to 2 decimal places. Okay, last bit of this question says, given as a metabolic rate of a cheetah is 9.12, given that the same relationship in part A holds for the cheetah, find the mass of the cheetah. So remember your formula now is r is equal to 0.58, what we've just worked out, times m to the power of 0.70, and we know that r is 9.12 is equal to 0.58 m to the 0.70, and that means 9.12 divided by 0.58 is equal to m to the 0.70. And again, if you just tally that up a wee bit, it comes out as 456 over 29 is equal to m to the 0.70. Just go over here to finish that off. That means m itself is equal to, and quite a lot of people like using the root button on the calculator, so it is a 0.70 root of 456 over 29, which seems weird, and I'm just going to do that just to check that. So that is going to be 0.7 root, and then put it using my fraction button inside. It's 456 over 29, and that gives me 51.21, and that's going to be kilograms, and that's the 2 decimal places on that, folks. A question I got, I would definitely put that thing back into this equation, into this part, and see, do you get 9.2, and you will see that you actually do, which is nice. So you know you've got the marks. Okay, last question we've got there. It says a jeweler designs a titanium earring in the shape of an open rectangle with 3 sides, as shown in diagram below. So 2 sides are of length y millimeters, and the third side is of length x millimeters. The total area of the rectangle must be 450. Express y in terms of x. Okay, so x times y, the area, must be equal to 450. So express y in terms of x, that means y is equal to 450 divided by x. I'll express y in terms of x. I think that's what we've done. We've done it. Happy days. Next part of the question says, show that an expression for the length L, millimeters of titanium used in the earring, can be written as L is equal to x plus 900 over x. Right, remember what we've got. Your length, you've got this bit, which is L, this bit, which is x, and this bit, which is L. That's your length. So your length is going to be y plus x plus y. You could say your length is x plus 2y. And we already know that y is equal to 450 over x. That means L is equal to x plus 2 times 450 over x. So L works out to be x plus 2 times 450 is 900 over x. And that is it done. Okay, I think we're on to our last bit of this exam. We are indeed. Since hence, using calculus, find the minimum length of titanium that can be used, showing that it is minimum. So your L, remember, was equal to x plus 900 over x. Write that in index form. First of all, x plus 900, x to the minus 1. And then this is a differentiation maximum minimum problem. You're going to differentiate this thing, and you're going to get 1 minus 900 x to the minus 2. And then we're going to put that equal to 0. So put 0 equal to 1 minus 900 x to the minus 2, which means 900 x to the minus 2 is equal to 1. And you can then write that. It makes it a wee bit easier if you write it back as 900 over x squared is equal to 1, which means 900 is equal to x squared. And then that means x is equal to the square root of 9 positive or negative square root of 900. But it's only going to be that, as it's going to be, I think it was millimeters, wasn't it? It's only going to be the positive one. You'll ignore the negative, so we'll write that in. We'll just say ignore negative, as it is length. So you're not going to have a negative length. Okay, so we've done all of that. It says hence using calculus, find the minimum length. We've only found x, we have to find the rest of it, but we'll prove its minimum. So we're going to do that by looking at d2l by dx squared. So if you do your d2l by dx squared, so differentiating this thing, you will get 1,800 x to the minus 3. So when x is equal to 30, d2l by dx squared is going to be equal to 1,800 times 30 to the minus 3. Don't really care what it is, but I just care it is positive. Therefore, it is a minimum. So your answer, it says, read the question again. It says, hence, using calculus, find the minimum length of titanium that can be used as showing that it's minimum. We need to find the whole length. Your length formula, remember, was 30 plus 900 over, x plus 900 over x. So that becomes 30 plus 900 over 30, which is just 30 plus 30, which is a total of 60. And I can't remember what the units are in this question. Where are we? Millimeters. It was millimeters. So 60 millimeters, and that's done. Okay, just check. Last thing. This is the end of the exam of the question paper, and you know you're sort of just go back over your exam, check it for any silly mistakes or any go over any questions that you may have had trouble with.